Hi guys, this is Math 116 section 5.1, and this section is all about exponents and exponential functions. And I'm amused because I'm thinking you guys must be really happy because you are done with matrices, and the Gauss-Jordan method and the simplex method are both behind you. So this section is a bit of a relief from those two sections. So the first thing to keep in mind with this section is it's all about exponential functions. So in this case, f of x equals a to the x. This is an exponential function because the function part, the variable, is in the exponent. And this right here is a number, and they call this the base. Okay, so if you had y equals 3 to the x, this is an exponential function, and you'll notice that's different from y equals x cubed, which would be a polynomial. So the two things you need to know in this section is one, how to graph an exponential function, and two, how to plug the numbers for x into your calculator and find answers. Plug into the calc. Plug into calculator. So let's do step one, how to graph it. Suppose we have something like this, question number 5, and it says y equals 4 to the x, and you're supposed to graph the function. So my graphing expectations are fairly minimal for you guys. I don't expect straight lines, clearly, because I can't draw them. So here's a couple of ways to get started with graphs. Plug in some numbers. How's that for exciting? So let's start with x equals -2. So that means y is 4 to the -2, which is 1 over 4 squared. So that's 1 over 16. That's a small number. It's a fraction. If we let x equal -1, we get 4 to the -1. That's 1/4. If we let x equal 0, we get 4 to the 0, which is 1. And if you forget this, try it on your calculator. 4 to the 0 is 1. Plug in 1, you get 4 to the 1, 4. You'll probably do these much faster. And you don't have to make a chart like this. If x is 2, you get 4 squared, which is 16. So if you were to graph this, I'm starting on the bottom here because I'm noticing my y's are never less than 0. That's the thing about exponential functions. You're not going to get a negative number down here. So when x is 1, right, or when x is 0, y is 1. X is 0, y is 1. Right? These are the zeros. Let's let x be -1. Y is 1/4. So it's like there. I'm plotting some dots. We'll connect the dots soon. When x is -2, y is 1/16. That's a very small number. So you can see on this side, the line goes like this. It just slowly starts to approach 0. 0 is in fact the asymptote, y equals 0. And as x gets bigger in this direction, in the negative direction, you know, as it hits negative infinity, this starts to approach 0, but it never actually really gets to 0. And now let's go back up here. X equals 1. Y equals 4. 1, 2, 3, 4. You see why my graphing expectations are minimal. We're going to blow off the chart soon. X equals 2, y equals 16. Boom! It's way up there. It's off my computer screen. So you just kind of do this. And like, so much for connect the dots. Come on, hit that point. Anyway, something like that. And this would be fine if I asked you to graph something for a test. Or you can be super fancy and do it like this. This is a graphing program. Clearly much nicer. And if I zoom out, you can see the bigger points. So this is the basics of an exponential graph. Notice it's not exponential, it's exponential because it's exponents. They grow very quickly, and as x gets bigger, they jump whoom way up really fast. And this is why we study exponential graphs, because that is how many things in our world grow. Lots of populations. If you were looking at the population of frogs in some place that didn't have a natural enemy for frogs, and you introduced frogs, they would leap up like rabbits in Australia, right? And if you're growing, if you put money in and it's compounding, your money does not grow in a perfect line. It grows exponentially. And the national debt grows exponentially. So there's lots of natural phenomena and things in our life that have this exponential growth curve. Bacteria, that's fun to think about, isn't it? Okay, let's look at another one. This is question number 29, and this is the other part of it, which is I want you to be able to plug these numbers into this equation. It says compound interest. Compound interest. If $1,000 interest. So we have $1,000 is invested for X years, right? Invested for X years at 8%, compounded quarterly. That means they're collecting the interest and adding it to the amount every quarter, every 3 months. Compounded quarterly. The future value is, here's the formula for future value. S always stands for future value. Why? Because Superman's from the future. I'm making that up. Superman is not from the future. And that S does not stand for Superman. 1.02 times 4 to the X. Here's the formula for future value. So what is the future value of your money? And the question says, what amount will result in 8 years? What amount will result? How much money do you have in 8 years? If you're investing $1,000 and it's compounding quarterly at 8% in 8 years. So here's how you answer this problem. You should definitely be able to answer something like this on a test. So when they say in 8 years, they mean when X equals 8, what does S equal? So the future value, you just plug 8 into this equation. 1.02 times 4 times 8. Okay, and now you do this on your calculator, and on your calculator you're going to want to type in 1.02 raised to, do you see that cap button, then parentheses, 4 times, like a little star, 8, and then I would hit enter, and then times 1,000, like that. And you should get 1884 and 54 cents. That is the amount. So this is an example of what I mean when I say you should be able to plug a number in and use these exponential functions somewhat smoothly. So that is the beginning of exponents. Coming up next is logs, which people find a little more slippery.